Alright, so let's go ahead and start putting in our source code, and we'll start with our pound includes. So we have pound include IOStream, then we need to have pound include string, okay, since we're going to have some variables that are going to be of type string, and then using namespace space standard semicolon. Okay, so now we're ready to start typing in the main function. So let's come down a couple lines and type in int main open paren close paren, and then come down a line and type in an open brace. And then if you want to, you can select the rest of this pseudocode here, and we'll just tab it over. So once you select it, you can hit the tab key and it'll tab all of that pseudocode over, since we want to have all of this inside of the main function. And also at the very bottom here, you can put in a close brace. Alright, so now we're ready to start typing in our main function here. So let's come down and do get the seed color. So in order to get the seed color, we need to have a variable that's capable of holding whatever color that's typed in by the user. So we'll declare a string variable, and we'll call it seed color. And we'll set it to the empty string. So we've got our declaration statement here. Now, one thing that I want to point out that I haven't pointed out before is that whenever we declare variables and they're a multi-word variable name, the convention is, or the convention that we're using, is to have the first word lowercase, and any subsequent words, they will be what we call camel case, meaning that the first letter is capitalized and then the rest of the letters are lowercase. And this actually aids in being able to see that we do in fact have a multi-word variable. So you can actually see the delineation because we have that uppercase C there. Again, this is just a convention. It's not required by the compiler. So you could name it, X, but that's not really indicative of what this variable does or means. So we want to have a variable that holds the seed color, so why not name it seed color? Okay. So then once we have that, we can then have a prompt to the user using our cout. So we'll do cout and say enter the seed color. And we'll put in parentheses here, red or blue. And we'll assume that we have good users for right now, and they type in red or blue. They don't type in purple or green or hamburger or something like that. So once we have the prompt there, then we can read in whatever they type on the keyboard. So we can use our cin, and then what we will want to do is store whatever they type in into the variable seed color. And that's basically it. So this is nothing new. We're just using some of the things that we had learned from our previous programs. So get temperature. In the case of the temperature, we will want to have that as some sort of numeric value because we'll want to compare it to other numeric values. So we'll store this into an integer value since I guess you could store it into a double. Our temperature may have a fractional part. For right now, we're going to say that our temperature is not going to have a fractional part. So we'll just put it in an integer variable. So we'll do int temp and set it to 0. So initialize it to 0. And then we'll do cout. We'll say enter the temperature. And maybe we'll put F here to indicate Fahrenheit. Even though we're really not keeping track of units. Units are important but for this program we're going to ignore the units related to temperature. We'll just add that in there for fun, I guess. So then we'll do cin and then use the extraction operator and type in the variable name where we want to store the temperature that they type in. And then the next thing we need to do is get the soil moisture. So this is also going to be a string variable, and we'll just call it soil moisture. Okay, and we'll assign it to the empty string or initialize it to the empty string. And cout, and then we'll say enter the soil moisture. And then we'll put wet or dry in parentheses here. So sort of prompting the user what we expect them to enter in. All right. Now, if the user goes in and enters in something besides what we're expecting, our program is not going to be able to handle that. At least not the way we write it now. We may come back and change it, or in later videos we'll modify this so it actually does a validation of the input. So let's see, we need to have the variable soil moisture here. Okay. So now, once we have our input for seed color, temperature, and soil moisture, we can start making some decisions. So we're getting into some new syntax here. So far in our programs, program 1, 2, 3, and 4, all of our instructions have been one right after the other in sequence. So now we're looking at having some sort of choice or alternative. We're making decisions. And we'll branch off to one set of code based off of what decision is made here. So if it's red, we'll look at these set of choices, and if it's blue, we'll look at these set of choices down here. So the syntax for testing to see if something is true is just a simple if. So almost like our pseudocode, we can say if and use our variable called seed color and check using our relational operator equals. And remember that to test for equivalence, we have to use equal equals, not just a single equal. Single equal means assignment, double equal means equivalence. So here we want to see if the seed color is red. So make sure you put red inside of the double quotes, otherwise it will not be seen as a string. So we're trying to compare one string, which is our one variable here called seed color, which is of type string, to a string literal, and this string literal says red. Alright, so I'm going to put open brace, and then I'm going to put close brace right above the pseudocode for if blue seed. So what we're trying to define here is the body of this if statement. So the body is defined by the open brace and the closed brace. So we're saying that if the seed color turns out to be red, then we want to look at testing these set of actions here. Okay. And the other thing that we want to do is come down below and test to see if, we'll say if seed color is equal to blue, we'll do these set of actions down here. Okay. So we'll come down and make sure we have our closed brace. And the nice thing about Eclipse, it actually lines up our braces. So if you have an open brace and a closed brace, it should automatically align those braces for you. The other thing I should point out about these if statements here, they have to test a Boolean expression here. So whatever we have inside of parentheses, if parentheses something, close parentheses, that thing inside of parentheses has to be a Boolean expression, meaning it has to resolve down to a true-false value. If it doesn't resolve down to a true-false value, then we'll end up with a syntax error. All right, so I'm going to just focus on the red for right now. So if the temperature is greater than or equal to 75, so check out how this source code here, the C++ code, is very similar to the actual pseudocode. So if temp is greater than or equal to 75, then we want to do these set of actions. And I'll put the little close brace in here. Otherwise, we do these set of actions. And the way we go about doing otherwise is we're going to use the keyword else. So we say else, open brace, and then I'm going to come down here and type in the close brace and make sure it's inclusive of our pseudocode for outputting mushroom. So we could have used else here for our pseudocode, but I just used the term otherwise. So all that's saying is if we have an if statement and that if statement fails to be true, and the only other alternative we have, so in this case, the only other alternative is if that's not true, if the temperature is not greater than or equal to 75, and we've determined that we have a red seed, then we know we end up with a mushroom. So we don't need to have another condition here. So you don't have to go in here and write if temperature is less than 75. Because that's the only other, whoops, I forgot my open paren. So we don't have to go in there and write this expression. Now we could do that. There's nothing wrong syntactically with doing that expression there. It's basically doing the same thing that we had before. But there's no reason to test to see if the temperature is less than 75, because if we fail here, if this turns out to be false, then we know the temperature is less than 75. So we can just say else. Okay. All right. So What about if the soil is wet? So we can do a similar test as we did before with the seed color. And this time we'll do soil moisture. So soil moisture. And test to see if the soil moisture is equal to wet. If that turns out to be true, then we'll do our output statement. And if the soil moisture, if I can say it right, turns out to be dry, we will do this output statement. Okay. And you could actually do the same thing here. As opposed to doing two if statements, you could actually do a if and then you could do a else, assuming that the user, you knew that the user was inputting wet or dry. So if they didn't input wet, then you know that they inputted dry. So we could in fact make this an else statement if you wanted to. I'm going to leave it in here as an if statement for now. Maybe we'll come back and change it. So in order to do the output, we would do cout and then just output a sunflower would grow. I'll say a sunflower will grow. All right. And down here we'll do cout and do a dandelion. Let's see. All right. So we have that. We may want a new line character in there, so let me go back in here and put a new line character. All right. So we have that.